In this video, I will show you how to obtain the current I0 t by using mesh analysis. This circuit is already transformed to frequency domain, so please check out the original circuit in time domain from my previous video. Okay, let's start mesh analysis. First thing to do is identify how many loops for this circuit, then write KVL for each loop. But before you write KVL, ask yourself either this circuit has a super mesh. If the circuit contains super mesh, so you need to write KVL and also KCL. Okay, this circuit has 3 loops, so I name this by I1, I2 and I3. Before we start to write KVL equation, do you see any super mesh in this circuit? Yes, it is here because the current source is between these 2 loops I2 and I3. Okay, for this circuit, we should have 3 equations. The first one is KVL for this loop and KVL for super mesh that combines I2 and I3. And the last one is KCL for super mesh. Okay, for KVL loop I1, let's start from here, negative this source, and sum up all the impedance from this loop I1. So plus 2 plus J10 I1. Then minus this J10 I2. Why minus? Because this I2 is opposite direction from this I1. I1 is going down, but I2 is going up. Now let's arrange this equation by I1, I2 and transfer this to the right side and name this by equation 1. Okay, for KVL super mesh, sum up all elements in loop I2 and I3. So here we get 4 plus J10 current I2 minus this J10 I1 because I1 is opposite direction of I2, and then plus with negative J0.2 I3 equals to 0. Okay, you can arrange this equation by I1, I2 and I3 and name this by equation 2. For KCL super mesh equation, you can choose this node or this node. I choose this node. This is easier node compared to this node because this node has 3 branches, but this node have 4 branches. For KCL is I in equals to I out, so I3 plus 5 equals to I2. So now we get the third equation. Okay, let's focus on the question. The question asks I0, and this I0 is same direction of this I2. So means that I0 equals to I2. From equation 3, we have I2 here. Since I2 equals to I0, so we don't want to eliminate this I2. So we arrange this equation by I3 equals to I2 plus 5. Then substitute into equation 2. From equation 2, replace the I3 here. Then the equation becomes like this. I name this by equation number 4. So now we only have 2 equations. We focus on this I2 because I2 equals to I0. We can use Cramer's rule to get this I2. For solving equation using Cramer's rule, please check out my previous video. By using Cramer's rule, you should get this determinant and determinant of I2. Then I2 will be 1.75 angle negative 40, and this I2 is equals to I0. The question asks I0 t. This is in time domain, so we must convert this phasor domain value to time domain. So the last answer of I0 t will be 1.75 cos 2t minus 40 degree amps. Okay, that's all for mesh analysis.